Hello everyone, very good evening. So I'm not speaking anything, that's why I'm not audible. So we'll start very shortly. Okay, give me just 2 minutes. I will be right back. So once again, hello one and all. Good number of people have joined, and it seems we are good to go for today's session. All set? Everyone ready? Great, great. So is my screen visible? So today I'm experimenting with the black screen. So let's see how it goes. Okay. Uh, the white screen is irritating my eyes a little bit. So like I'm not able to focus on the white screen somehow. So I'm experimenting with the black screen for today. Okay. Uh, Let me just. It's a different tool. Where is the eraser? Okay, here it is. Okay. So I'll use a bolder font so that it's clearly visible. Okay. Mhm. So the idea of today's class is to solve problems on 2D arrays. And let me know, did we discuss 2D array lists in the case of the beginner batch? I'm not able to recall. I think we only discussed 1D array list. We did not discuss how a 2D array list is created and stuff, right? Great. No issues. I will teach that topic as well as a part of this class along with the coding part. Okay. So don't worry. We'll do it today. So let's start the class with a quick recap of 2D arrays. Who remembers what a 2D array was? Where it was used? Who remembers what is a 2D array? Okay. It's kind of a grid or it's kind of a matrix. Great. So this is how a 2D array would look like. And we discussed that you can create a 2D array in Java. You can say int square brackets followed by the name of the array. This is equal to new int, and you specify, okay, I need these many rows and I need these many columns. This is how we did, okay. And we discussed that this kind of 2D array is going to have fixed rows and columns. The row number starts from 0 and it goes till r minus 1, and the column number also starts from 0 and it goes till the number of columns minus 1, okay. And every cell has index. For example, this is 0th row and the first column, 0th row, sorry, 0th row and 0th column, 0th row and the first column, and so on. We can do numbering for each cell. So we can say, okay, this cell is in the ith row and it is in the jth column. So this is how we refer a particular cell. And maybe if you want to put some value inside it, you can say, okay, I'm going to store 20 in this particular cell. This is how we work with it. So can you guess what a 2D array list would be? What would be a 2D array list if we know we have a 2D array? What would be a 2D array list? Great. So first of all, tell me, do you remember what is an array list? What is an array list? Who will tell me? Okay. So array list is just like an array, but it can grow in size. An array that can grow in size. It's more dynamic. It's a kind of a dynamic array. Yes, that's what we discussed. So array list is a dynamic array. Great. So what is a 2D array list? A 2D array list would be a dynamic 2D array. Now, if I have, suppose, a 2D dynamic array, so in what direction will it go? Will it grow along the rows or will it grow along the columns? Which direction it will grow? People are saying both, which is absolutely correct. So it can grow along rows and it can also grow along columns. That means you can add more number of rows inside the array list. So growing, sorry, I just written the reverse. So we have columns this side and we have rows this side. So growing along the rows direction would mean that you can add additional rows inside it. You can say, okay, I am going to add a row inside it, and that row can be added easily, right? Growing along the columns would mean that, okay, I can add some additional elements in a particular row. So it can expand in both directions. So let us look at the memory level, or maybe at the coding syntax first, that how this array list can be created, okay. So now you know that it is a array list which is made up of objects, okay. And I call this as some array 2D, let's say. So can you tell me what is each object inside this 2D array list? What is each object? So each row can be treated as one object. So it has rows. Each row can be treated as an object. Each row is a array list object. Yes, each row is a 1D array list object. That is absolutely correct. So what data type it would be? It would be of the type that, okay, I have an array list which is made up of another array list, and that array list is made up of what kind of data? What kind of data we are holding in this array list? So right now, let's say if they're numbers, so it would be some kind of data. So it would be of the type integer. Absolutely correct. and I call this as array 2D, and I say okay, I want a new array list to be created. So this is how you will create a new array list, right? So right now we have not specified the initial capacity. So if you remember that in some cases that we have a optional parameter here, we have an optional value which tells me the initial capacity of this array list. So right now I have not given any value, so JVM will decide what value to keep for the initial capacity. So it's completely optional. You can have some value or you cannot. You can skip giving this value, right? So now, so what is this array 2D? So let's look at this. So array 2D is a variable that is holding the address of this array list. Okay. Let's say currently I don't know any size. So by default, let's say the capacity is 4. Let us just assume the capacity is 4. It can hold 4 arrays inside it. Do you remember how the arrays are stored? Will the array list object will it be present inside this bucket or will it be present separately on the heap memory? It will be stored separately on the heap memory. Absolutely correct. So now what I want to do is I want to link the 0th bucket with a new array list. I want to say, okay, there is a array list here which contains 4 columns. So this array list becomes my row 0. Similarly for row 1, I can say, okay, I have something. I call this as row number 1. I have something, I call this as row number 2, right? And I have something, this becomes row number 3. So together, this entire data structure forms a 2D array list. Now, we are interested to know that can each row grow along its direction? Can we grow each row? The answer is yes, because each row itself is a array list. Great. So each row can be expanded. Can we grow the number of rows? Can we add more rows to this array list? Of course, yes, because this green array, this is also of the type array list. Hence, we can also grow the number of rows. Okay, and each row is an array list. Hence, you can add more columns in any row. No, if now the question is if row 1 grows, all rows grow automatically. The answer is no. Each object is independent. So this object has no relation with this object. So if this object grows, the second object will not change. That means it will be kind of a jagged array where every row can have a variable number of columns. Every row can have any number of columns. Got it? Are you getting it? So this is how the memory representation of 2D array list would look like. So if you want me to show you in the form of code, I can show you in the form of code as well, right? So let me create a new file. This I did in other batch. So let me just say 2D array list demo.java. So yes, coding screen is going to be white, but we have PSVM, that is our main method, and let's create a 2D array list. So I will say okay, I want an array list which in which every object itself is an array list, and I call it, give it some name. and I say okay, create a new object here. Okay, so you can define some initial capacity, let's say 5. That means it can hold at least 5 rows, but those rows are not yet created. Those rows will get created once we create a new array list for each of those rows. Okay, so right now it only creates the green array. The purple array is not yet created. So when you write like this, it only creates the green array. It does not create the purple arrays which represent every row, right? So what should I do? What should I do? Let me create a 1D array list and add it to the 2D array list. Does it make sense? Yes. So basically, I'm creating one object and I'm going to push it to a 2D array list. Okay. So how do I create a 1D array list? I say, okay, I have a array list which is made up of integers. Let me call it as some row 0, and I call it as new array list. And one option is that I define some data here, or another option is I can add some data later. So I can say row 0 dot add 1, row 0 dot add 2. So where is this add function going to add? What does this add function do? Who remembers it? Row 0, but where? At the end of every row, right? So it's going to add it to the end of uh, the every row. So if I simply say row s out row 0, you will see the numbers 1, 2, 3. Okay, so it's a 1D array list. Okay, great. Now if I push it to a 2D array list, how do I do it? I say okay, array 2D dot add row 0. Does it make sense? So I'm pushing a 1D array list object inside a 2D array list, and I'm going to print the 2D array list. I say okay, s out array 2D. Okay, now the print function knows how to print an array list, so we don't worry about the printing part. Now if you look at this structure, it gives me a 2D structure. That means this is an array list which contains only single row, right? You can add more rows. You can say okay, I want to create another row, and this time I don't want to use the add function to create it. I will give some kind of initial data in that row. So I can say array list of integers. I say row number 1, this is equal to new array list, and I give some data here. Okay, so now one way is to uh, give a parameter like arrays dot as list, and here you specify a sequence of numbers. Let's say 20, 30, 40, 50, something like this. This gives something of the type list to us, and the array list is able to create a row out of it. Okay, so we are giving some data here, and array list knows how to create row out of it. So I can say array list 2D dot add row number 1. So how many rows I will have now? I will have 2 rows, and the first row has 3 elements and the second row has 4 elements. So you can see each row can have different number of elements inside it, right? Great. So now you might ask, is there, if I add row 0 2 times, then it will create new memory. No, it will not create two memory. If you say I'm adding row 0 2 times, what is it going to do? It's going to push the same object reference twice in the array. So that means if you say, okay, I have another row 0, so there is a object reference to the same row. So let me show you. If I say, okay, array list 2D dot add row 0. So row 0 is the address of the 0th row. I'm pushing it in the 2D array list, right? Now if you look at this, that okay, is it creating a new row or is it changing the same, is it the same row? Who will tell me at memory level, is it a new row or is it the same row? Okay, let's try to do one operation. So let us try to update this element. So how do I update this element? Can I say in the 2D array list, give me the second row? What is array list of 2D dot get? 0, 1 and 2. This is what the objects are. Give me the second object. And how do I get this element of the second object? Can I say get the zeroth element? Okay. But I can say I don't want to get it. I want to set it. I want to set the zeroth element and I want to set this as 10. Or let me say I want to set this as 55. So what do you think? What's going to happen? Let's go and print this 2D array list. You see, the element also got changed here and it also got changed here. So what does it mean? Is it creating a new row or is it the same row? It is the copy of the object reference. Okay, so what I'm trying to tell you is that now suppose this row had some address. This row had some address 206. So the bucket 0 is storing 206 and row 0 is also storing 206. You said, okay, I will push row 0 once again. So it is also storing 206. That means both the locations are same. They're pointing to the same row. Are you getting it? Why this happened? Now you said, okay, through this location, I will make this element as 55. Now the changes will reflect in both. Got it? Tell me yes or no. Any doubts in this? No doubts? Rahil says, can you explain the syntax part? Which line, Rahil? Line number 18. Okay, so see, arrays is a predefined class. Okay, it has a function called as list, which accepts multiple numbers. Okay, and it creates a list kind of a object out of it. So I say, okay, I want to initialize a new array list from this list of numbers. That's it. So it's a way of initializing a array list. Got it. Chirag says with m rows and n columns. What does it mean here? Won't the 2D array dot get 2 comma 0 work here? No, it will not work here. See, if you have an array list and you want to get a particular index, so you have to use the get function. Now what is happening here? If you want to, let's suppose you want to iterate over the 2D array list. What do you have to do? So how do I get the number of rows? I say, okay, I want to iterate over the rows. How do I get the number of rows? Who will tell me? Dot size of what? Can I say array list 2D dot size? Great. Row plus plus. So array list 2D dot size will give me the number of rows I have. Absolutely correct. So it will effectively give me these buckets 1, 2, 3, 4, 5, whatever it is. So these buckets. Great. Now in the ith row, I have variable number of columns. Okay, I have variable number of columns. So can I say int for int column equal to 0, column less than what? How do I get the number of columns in the ith row? For that, I have to first get the ith row. So I have to say array 2D, give me the ith or the rth row, and then give me the size of that row. So that will give me the number of elements in that row. That becomes the columns. and I say columns plus plus. Okay. Now you want to print every element. So can I say s out array list of 2D? Again, give me the ith row, give me the rth row, and then give me the cth column of that row. So I have to use the get function two times. Array list 2D dot get gives me a row, which is again an array list. So array list, this is a 1D array list. Dot get of 1D array list gives me the integer. I'm getting the integer element here. Okay. So now if I print this, I will get that particular element. And after every row, I can say I will print a new line. Okay. This will give me, this will print the entire 2D array list for me. Okay. So this is what we are doing. We are iterating over the 2D array list that we just created. Chirag, I'm going to answer your doubt. So Chirag says, can you show a code of initializing the array list of m rows and n columns? Okay, so Chirag is saying right now we are just doing hard coding stuff. I don't like this. I want to use this in problems where I will have n rows and m columns. How do I do it? Okay, so let's create a function to read a 2D array list. Public static. What will be the return type? Array list of array list. Okay, and I can say okay read array list. It's a function that I'm going to create. Now in this function, the first step is to create a 2D array list, just like this. Okay. Now Chirag says I want the user to have n number of rows and m columns. All right, no issue. I can say okay, I will create a scanner. SC, that is new scanner system.in. I will read the number of rows. All right, so I can say scanner dot next int. Great. I can also read the number of columns. SC dot next int. Great. No issues. Okay. Now when you're creating a 2D array list, how much initial capacity should I reserve? So it is optional. Either you reserve it or you don't reserve it. It does not matter. The add function is still going to work. But it's a better thing to reserve because we don't want the doubling operation to happen too frequently. So we can say, okay, if we know these are the number of rows, we fix it. So here we define the number of rows, right? Now what I need to do for every row, for every row, I need to create an array list. Yes or no? I need to create an array list, the pink one, for every row. So right now we just created the green one. The pink one is yet to be created. So can I say for int I equal to 0, I less than the number of rows, I plus plus. And I say, okay, I'm going to add a new array list inside my 2D array. So that will represent one row. So how many columns should I keep in this row? M columns. All right, so I want at least M columns. We are done. Now what should I do? I also want to push some data inside these. I also want to push some data here. So first we created this, then we created this. Now we want to push data inside it. Then we will go to the first index, we will create this, and I will push data inside it. How do I push data inside it? What should I do to push data? Okay, I should put another loop as Monica suggests. So I can say for int j equal to 0, j less than m, because I have m columns, j plus plus. I will read a number. I will get some number that is scanner dot next int, and I will push that inside the ith row. So dot get the ith row and dot add the number that we have just learned. Adding the number in the ith row. Okay, that's it. So that finishes our work, and we can say return array 2D. So once you got the 2D array, you can print it in the similar manner. Let me just say that instead of creating a new array list, which is mm, I just commented this thing out. Let me just say that I'm going to read a 2D array list using the function read array list, and I'm going to print it. The read function is going to create and read it. So I say, okay, I want 3 rows and 4 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I get the 2D array list with 3 rows and 4 columns. Chirag, uh, does it answer your doubt? Okay. How about if you have variable number of columns in every row? So you can take input here. You can say, okay, tell me the columns in the ith row, and you can say, okay, whatever is the columns, I will create an array list of that size. So you can read it here itself. So you can also create a jagged kind of array list. Got it? That is precisely how you are going to work with the 2D array list if you face this in an online judge. So Siddharth says, so it will print 5523. Siddharth, for what part? We are done with the earlier part. What is your doubt? Can you go up? Okay, we can go up. So look at this code and tell me if you have any doubts. So this creates a container which is going to hold the object references for the arrays. And this is the place where we are creating the actual row objects. And this is the place where we are pushing data inside row. Is this the most efficient way? Yes, this is the recommended way. The loop at line 20 will take help rows of array list. Will take input of rows of array list. Yes. So we just created like first row, the zeroth row. So when I is 0, we said, okay, inside 2D array list, you push a new array list. So this creates a 2D array list of size m, or 1D array list of size m. Then I say, okay, for j equal to 0, j less than m, j plus plus, go and read these m elements. So now user is entering some data. So these numbers get I would mean that, okay, get me the 0th array list, which is this one. And inside it, add some numbers that I'm giving. Got it? All right. So I think even though it is initialized to m, that there is no problem to add more. Yes, there is no problem. You can say, okay, I want to add the number and I also want to add the square of the number. So even if you give more data inside it, it will be more than happy to accept. So m means at least m is already created, but you can go beyond m, right? So for example, 2 rows, 3 columns, 1, 2, 3, 4, 5, 6, 7. So now if you see that with 1 I have 1 1, with 2 I have 4, with 3 I have 9. So I have actually more elements here. Okay, so 7 will anyways will not get counted because we just gave three columns. So 4 and 16, 5 and 25, 6 and 36. So it's holding 2m elements, whereas we initialized only m. So that represents the dynamic nature of 2D array list. It's a 2D array. Okay? It's a dynamic 2D array. Okay, got it? You can also add additional rows. You can say array 2D dot add some additional row. Okay, some row like new array list, and you can do it. Dot get will only get the index, not the value. The thing is, it depends on what array list you are using the get function. So if it's a 2D array list in which uh, every object is there, obj obj obj, right? So if you say array 2D dot get 0, it will give me the object at the zeroth index. But I told you that this object is itself an array. So it gives me this object, which is the array list. Now inside this array list, I want to read this element. So I again have to say dot get 1. Or inside this array list, I have to add something. So I will say dot add 7. So it will add 7 to here. Something like this. Or if I want to update, I will say dot set. Okay. So if the get function is used with 2D array list, you will get an object which is an array list. If the get function is used with a 1D array list, it will get the object. In this case, the object is an integer. So it will give you whatever is at the ith index. It can be any kind of object, a 2D array, an array list, or an integer. Can there be an array list of an array? Possibly yes. You can have. There is a array class in Java. You can have an array list of an array. Okay, cool. All right. So if this is clear, we can move to today's class, which is on problem solving on 2D array list, 2D arrays. So now, when I say 2D arrays, it also means array lists. When I say array list, it also means 2D arrays. So interchangeably. So you can see we can solve any problem either using 2D array, or we can also use array list for the same problem. So these two data structures, they will be used interchangeably. Okay, so depending on how it is given to you, you can use it, which is efficient. See, if you know the size is fixed, you go with a 2D array. But if you know there can be possible expansions, you can go with a 2D array list. It's more dynamic. That's Otherwise they are equally good and bad. Okay. Can we change an array to array list? Yes, you can do it. So look for some library function that would be doing it. Arrays.toList. Okay, Sheetal says arrays.asList. So try out a function like arrays.asList. I think, and you will pass array here, and it should give some kind of a list to you. Okay, and yeah. As list or to list, whatever it is, I don't remember exactly. So just try it out. Okay, as list is there. Great. Okay, so I will start with very simple problem. Given a matrix like with m rows and m columns, I want to print the row wise sum. So how do I get the row wise sum? What should I do? Okay, two for loops. So what are the logical steps? Two for loops is okay, but logically, what we want to do? See, we want to go to every row, and then we need to calculate the sum of that row. That's it, right? So we need to say, okay, I will fix the row number as 0 in the beginning. I will find the sum. So I can say for I equal to 0, I less than the number of rows, which is, let's say, n comma m. I less than n, I plus plus. So this would be the first row. This would be the n minus 1th row, and this would be the nth row, right? Which does not exist. So I less than n. For every row, I need to initialize the sum equal to 0. Then I need to say, okay, I am going on this particular row, and how do I find the sum? That's pretty easy. I iterate over the columns 0, 1, 2. So I say, okay, for j equal to 0, j less than the number of columns, that is m, and I say j plus plus, and then I can say sum equal to sum plus array of ij. That's it. And after every row, I can print the sum. That's it. Okay. Now, if I initialize this sum outside, will it give me the correct answer? The answer is no. Okay. We need to reset for every row. Reset the sum for every row. That's correct. All right. So this will give me 1, 2, 3 plus 2, 5, 6. This will give me 11 and 4, 15, and so on. Okay. So this was actually a pretty easy one. Let me change the question, right? So let us change the question a little bit. So given the same array, I want to find out the column whose sum is the largest. Given the same matrix n of size m n cross m, right? Find the column with the largest sum. So this question basically tells you the row wise iteration, which we have already done a lot of times. How to iterate over an array list? How can we do it using a 2D array list? Sheetal, same way, right? So instead of writing aij, you have to write array dot get ij. That's it. That will be the change in case of 2D array list. It's more about the syntax. The concept still remains same. Yes or no? This is what you will do it in case of a 2D array list. Get the ith row and the jth column. That's it. Rest everything is still the same, right? So how do I find the column whose sum is the largest? Okay, my application has got stuck. So give me a minute. I'll restart it. Okay. So People are saying that write J first and then everything should be same. Need to find column by sum to get the column with the largest sum. Of course, yes. Of course, yes. Siddharth says three loops. Not really, Siddharth. We can do it in two loops, right? See, now if you want to find out the column with the largest sum, then where you should iterate? Can I say we need to iterate over the columns? We need to iterate over the columns, right? So can I say I will set the column to be 0, let's say zeroth column. So for column equal to 0, column less than m. I have m columns. So column less than m, I say column plus plus. Now what I need to set? What is the information that I need to track? One is what is the largest sum I have seen so far. One is the sum of the current column. So can I say the maximum sum I have seen so far is let's say very small, it's minus infinity, and I also need to find the column. So I also need to see what column is having this particular sum. Okay, so I can say the best column. Sorry. So can I say best column is not yet known, and I set it as minus 1. I do not know what column is the best column, so I just set it as minus 1 in the beginning, right? So there are few things to track. We need to find the column. We also need to find what is the largest sum, and we also need to know what is the current sum. So can I say sum is 0 for the current column? Then I iterate over all the rows. So row goes from 0, row is less than n, row plus plus. So now what's going to happen? So when column is 0, I am changing the rows from 0, 1, 2 up to let's say n minus 1. And I'm saying, okay, in my sum, I'm going to add what? Sum plus array of row comma column. Does it make sense? Now after this line, I will know what is the sum of a particular column. Suppose this is the column. I will get to know, okay, what is the sum of this column at this line. Okay, and what I need to do, I need to compare the sum with the largest sum I have seen so far. So can I say if sum is greater than the largest sum, then what I will do? What I will do? I will update two things. I will say, okay, that my maximum, uh, largest sum, this is now equal to sum, and my best column is this column. Okay, and the best column is this column. So this is what I do. So I go over all the columns. I say, okay, this has a sum 6, this is having sum 8, this is having sum 4. So after all the loops end, I will know the best column is 8. Sorry, best sum is 8 and the best column is this. So you need to make these two updates. So finally, when you're out of the loop, you will say, okay, I will print the best column. That will give me, okay, that this is the best column. Are you getting it? Come on. So how many loops we needed? So this is the outer for loop. This is the inner for loop. This is actually the outer for loop. This one, right? And there is a if condition here, right? So of course, yes, it's order of n into m because we have n rows and m columns. Great. Okay, so we have learned two types of iterations, right? Can you show how to do it in ArrayList? See, the thing is very simple. Uh, in case of an ArrayList, right? This question does not make sense for a jagged array because columns are not defined. See, in case of a array list, the only change that you will make is that everything remains same. It's about how do you access the 2D array list. Okay, so you have to say that okay, array dot get the row and then get me the column. That's it. That's the only change that you will do for a 2D array list. Same as the previous one, right? Gopinath, it's not really different. 2D array and 2D arrays, they are same. It's just that it's an array that can grow in size. Right now we are doing questions in which n and m are fixed, so we don't need to worry about it. Best column value in best column will be equal to column is will it be no, it's not double equal to, it's a single equal to. So we are doing a assignment. We are noting okay, what is the largest column we have seen so far. Okay. It will be the column ID, yes. It will be the column index. The column would be the index. So I will try to you avoid this color purple. It is not looking that bright. Okay. So we'll use brighter colors for the next question. Okay. One concept that often is sometimes helpful is diagonal iteration of a 2D array or array list, whatever it is, of size, let's say m cross n. Okay, now suppose I'm just simplifying this question. Uh, I just want to print two diagonals out of it. I just want to print the two diagonals of this array. For example, one diagonal is now suppose one diagonal is this diagonal, uh, and let's say the other diagonal is this diagonal. So can you tell me how I can print the elements which are along this diagonal? Any ideas? Okay, Swati says when I equal to j, print ij. Mm-hmm. Oh, diagonal means straight arrow. It's a straight arrow. It's not zigzag. So it means if you are in this cell, you will directly go in this cell like this. And here it means if you are in this cell, you will go directly in this cell. So always I equal to j, correct. Uh, right. So if you're talking about this diagonal, right? So you know this index would be 0 0. Yes or no? 0th row and the first column. This index would be what? 1 comma 1. This index would be 2 comma 1. Oh, sorry, 2 comma 2, 3 comma 3, 4 comma 4, and so on. Okay. So maybe after this index, we will not go here. We will actually go out of the grid, which is okay. Like from 4 comma 4, it will go into 5 comma 5. It's not diagrammatically correct. So hence, the output of printing this diagonal would be 1, 7, 13, 19, and 25. This is what I will get from this particular diagonal. So who will tell me how do I do it? What should I write to get all the elements of this diagram? So one option is, see, in this we have how many rows, right? We have 0, 1, 2, 3, 4, 5. We have 6 rows and we have 5 columns. So hence the index 5 comma 5, it will not exist because we have only up to 4 columns. So one option that people are telling is that, okay, we put a for loop for I, we put a for loop for j, and we check if I equal to j, we say, okay, we will print aij. Does it make sense? Yes, it does make sense, right? So when I is equal to j, we are printing aij. It is okay, but it's going to take order of n square time. Yes or no? So we go to every row and we go to every column. For every row, we are iterating over every column. So we check if I is equal to j, we will print aij, right? But can we do it in one loop? Just one loop? The answer is yes, right? So let's discuss the other approach. Can I say if I know the starting point, I know the starting point is, let's say x is 0 and y is also 0, the xy coordinate. So I can say, okay, the row number is 0, the column number is also 0, while some condition, I will see what the condition is. Can I say print x comma y or print array of x comma y? And how should I update x? What should be the next value of x? If this is x comma y, what is this x? What is the next cell where we have to go? So of course x is moving down, so this is x plus 1, and the column is going ahead, so the column is also incremented by 1, y plus 1. So of course we are saying x plus plus and y plus plus. Great. So we updated both x and y. Now what should I do? What is the condition should I put in the while loop? What is the stopping criteria? When should I stop? Or up to what point should I run this loop, right? So I need to make sure that I'm not going out of the grid. I'm not going outside the bounds of the array. Yes or no? So can I say at every moment x should be less than the number of rows? Let's say the array has n rows and it has m columns. So can I say x should be less than n always, and y should be less than what? M. Absolutely correct. Absolutely correct. And y should be less than n. So if this is true, that means I am inside the bounds of the array, then array of x comma y is a valid index, and this will print all the diagonal elements on this particular diagonal. So did you understand this approach? So what time will it will take? So it will take order of n time. Okay, or yes, it will take linear time. So whatever is the length of the diagonal, that will take, where n is the length of the diagonal. Why we add two condition? So Kintan, we are adding two conditions because two cases can happen. Na? If your array is having more number of rows, then if you start the diagonal iteration from, let's say, this index, you will end up here. So what got finished? What got finished? Your columns got finished. Okay. But if you have something like the other way around, if you have something like this, and you start your diagonal iteration from here, so what got finished? Your columns are still there, but your rows got finished. So I am saying, okay, I will print xy if I have both rows and columns that are available, only then I am going to access that. Got it? Kintan says got it. Great. Now I'm going to give you 5 minutes. You have to build the code for this diagonal iteration. The second one, you have to do it on your own. So I'm giving you uh, do it yourself exercise, and you have 5 minutes to try it out. And if you're done, then think about how do I print all diagonals. All right, so we have got so many answers. It's good to see you all trying it out. Rahul, Pranav, Shravani. So I think many of you have got it right. So Vinay, let's see. So we need a starting point. So since we are iterating in this direction from top corner to the bottom corner, I need to know what is the starting point. So can I say the row number is initially 0? Yes. What is the column number? What is the initial column number? Who will tell me in one line? M minus 1, absolutely correct. So we are at the last column, which is M minus 1. Great. Now I need to take a step in this direction. That means I'm still increasing the row number because we are going down, but I'm going backward. That will decrease the column number. Okay, so I need some condition while some conditions, and then I need to say, okay, print the element at the x row and the y column, and since we are going down, that increases the row number, and since we are going left, that decreases the column number. Great. Now the condition is that when we are going down, we can run out of rows. Okay, so that means at any point x should not cross the last row, so x should be less than n. And what about y? Since the columns are reducing, so at every moment y should be greater than or equal to 0. Y should not go beyond 0. So that is the correct condition. So if you did not understand this condition, please let me know. Y greater than equal to 0, Sheetal, it will not be less than, but it will be greater than equal to 0, because that is also a valid thing. Is it okay with everyone? Okay, so if this is okay, then let me give you something little challenging. What about all the diagonals? Yes, yes, we are coming to it. We are coming to it. We are going to discuss that how do I print all the diagonals, okay? So for that, I need to create one beautiful 2D array. It's a 0, 1, 2, 3, 4, and 5. 0, 1, and 2, right? So what I want to do, I want to go like this. This diagonal, this diagonal, this diagonal, uh, this diagonal, I guess. Am I doing it right? Looks so, at least. This diagonal, then this diagonal. Now there would be little change, so I'm going to change the color. I'm going to make it orange. So this is also a diagonal, and this is also a diagonal. Are you getting it? So this is what I want to do. I want to do the diagonal iteration. Can I say for the green set of diagonals, these are the starting points? Let's break this problem into two parts: the green set of diagonals and the orange set of diagonals. So can I say the green diagonals, they are beginning from 0, they're starting from the 0th row and the 0th column. Then the next diagonal starts from 0th row and the first column, 0th row and the second column, 0th row and the third column, 0th row and the fourth column, 0th row and the fifth column. That is actually the last column, 0 comma m minus 1. and this is the first column, that is 0 comma 0. Does it make sense? The starting points of these diagonals. So can I say that once I know the starting point, I can apply the same technique that we just discussed in the previous problem? How do I iterate diagonally? Can we do the same thing for each of these points? The right diagonal. Okay, we discussed how to iterate on the right diagonal. This one, the second one. Can we just apply the similar technique with the change value of x and y? Yes or no? Come on, guys, let me know. Does it make sense? I know how to iterate on the right diagonal, right? So with the change starting point, I can apply the same technique. So what I can say, okay, I want to iterate on the zeroth row to get these data points. Okay, so I can say for the column number j equal to 0, j less than, I have, let's say, m rows, I say j plus plus. So I'm going to iterate over these numbers. 0, 1, 2, 3, 4, 5. I'm iterating over these numbers. Okay, so this is m and this is n. So I'm iterating over these numbers. I'm iterating on columns actually. Iterate on zeroth row columns. So j would be less than m. Does it make sense? Now I need to pick a starting point. So can I say the row number is always 0? So x is always 0. And the column number is equal to j. Yes or no? See, what is this column number? So all these are of the type 0 comma j. If I generalize them, so y is equal to j. So while the condition is still same, that since we are going in this direction, so we have to remain below the nth row, and we have to ensure that the y does not go beyond the zeroth column. So y should be greater than equal to 0. Then I can say, okay, print array of x comma y, and I do x plus plus and y minus minus. That's it. Does it make sense? And I say, okay, print a new line after every diagonal. So this will print the first diagonal, the second diagonal, the third diagonal, and so on. Yes, Sheetal, you are right. Y is greater than equal to 0. See, if you start from this third location, so what you're doing, you're saying, okay, I started from 0 comma 3, I came here, which is x plus plus 1 comma 2, I came here, which is 2 comma 1, and I came here, which is uh, 3 comma 0. But you will not hit this because the third row does not exist. So you will print these three cells, 0 comma 3, then 1 comma 2, and then 2 comma 1. Does it make sense? Everyone, please let me know. So same as the previous one. Okay, previously we did y greater than equal to 0. That means till y is greater than equal to 0th column, let's print the diagonal, right? Sheetal, if I do not keep this condition y greater than equal to 0, suppose you start j equal to 5, okay, for this column. Sheetal says, what happens for this column, right? See, it will depend upon how many rows we have. If I start from, let's say, 0 comma 5, I will end up at 1 comma 4, I will end up at 2 comma 3, and after this the value of x will be 3 comma, the value of y would be 3 comma what, 2. But we know that this will violate the condition, right? That x is not less than the number of rows. The number of rows is 3. Is x less than 3? The answer is no, right? Yes, we have not included orange diagonals as of now. That is part 2. This is part 1 of the problem. So Sheetal says right. So it will stop here. That means for the fifth diagonal, it will print these 3 buckets. The loop will stop because this condition is failing, not because y is greater than equal to 0. Sheetal says right. So now part 2 would mean that we want to do orange diagonals as well. So what change should I make to have orange diagonals covered? What should I do to have orange diagonals covered? Last column of each row, absolutely correct. So we need to have a starting point, which is the last column of every row. Starting from which row? Should I start from the 0th row, or should I start from the first row? See, if you start from the 0th row, it will repeat this diagonal, which means we should not start from here. We should start from the first row. So can I say, okay, I will start from the row number 1. Let me call it as I. Let me call it as I equal to not from 0 but from 1. I will go for all the rows I less than n, I plus plus. So that means I'm iterating over these rows. Where should I set my xy? So what should be my starting point? X comma y. The last column of the ith row. So column number is m minus 1. What is the row number? I. Got it? Yes or no? And after that, you can simply put this code again here. You copy it here and it will work. Because the diagonal part is still same, the only starting point has changed. So that will give you the part 2 of the problem. Are you getting it? Chirag says, what if the matrix is square? No issues. It will work fine for the square matrix as well. This software doesn't look that good. It's made for iPad, actually. So where are we? We are here, right? Okay, let's see what happens if you have a square matrix. Let's say we have a 4 cross 4 matrix. So it would be even easier. So first you will have, in the first part you will have this as a diagonal, this as a diagonal, this as a diagonal, and this as a diagonal, the orange part. And the green part, it will still be like this: one diagonal, two diagonal, third diagonal. So you again starting from row number 1, row number 2, and row number 3. Okay, and here you're starting from column number 0, column number 1, column number 2, and column number 3. So once you get the starting points, then the problem becomes very easy. Did everyone understood this? So this is what we are doing. This is how the two parts have been divided. Okay, got it? Great. So now, do you want a coffee break, a tea coffee break? All right. So let's halt for a 10-minute break. We will resume at 10:35. What about when we code for all directions, like top to bottom, bottom left to top right, top right? So Pranav, it's it's going to be simpler, right? So I've showed you one direction. The other directions are also very similar. Now suppose if you want to go in this direction, and you know the starting point x comma y, so going in this direction would mean that you are decreasing the row number and you are changing the column number. So you are saying y plus 1. Okay. And if you want to go in this direction, we have already seen. If you want to go in this direction, we have already seen. And if you want to go in this direction, like this, then it would mean from x comma y you are reducing the row number and you're also reducing the column number. Okay. So accordingly you need to put the constraints on the stopping criteria, that okay, I'm not going beyond the boundaries. So it's going to be very similar. It's going to be very similar to this one, right? So just need to make sure the updates and the conditions are correct. Okay. What about the time complexity of this approach? So if you look carefully at the loops, we are going to we are visiting every cell once. So what will be the time complexity of this code? How many cells we have? So we have n into m cells. That means this is the time that we are taking to iterate on the complete matrix. Okay. So I hope these doubts are clear, and we'll meet at 10:35. All right. So have a break. All right, so welcome back, everyone. So now we are going to give you another problem to think upon. Have you ever heard about transpose of a matrix? So, what does transport mean? Transpose means yes. So, basically, taking a mirror around the diagonal that will convert your rows into columns and columns into rows. So, let's look at a particular example, right? So, if I have something like this, if I have uh, a 4 cross 4 matrix, and it is possible if it is a n cross n matrix. Okay, so it should have same number of rows and columns. Let's say if the elements are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So transport would simply mean that you take a mirror image along this diagonal. Okay, that means the elements which are on the diagonal, they will remain same. So 1, 6, 11, and 16, they do not change, but the other elements like 2 3 9, so 2 will get swapped with 5, so 5 comes here and 2 comes here, like this. 3 will get swapped with 9, so 9 comes here, 3 comes here. This 9, sorry, it's 9 or what? It's a 4. So 4 comes here and this 13 comes here. So what I'm doing, I'm taking a mirror image along this diagonal. So can you tell me what will come here and here? What values will come here and here? What about the first box? 10, of course, because if you take a mirror image, 10 and 7 will get exchanged. Great. So 7 will come here. Great. What about this box? So look at this and this. So 14 and 8, absolutely correct. And this would be 15 and this would be 12. So this is how the transpose is going to look like. Great. Now, how do we actually look at it from an index level? Okay, let's see what is happening to indices. So we have some indices which do not change. So basically, the indices along the diagonal, they do not change. 0 0, 0 1, sorry, 1 1, 2 2, and 3 3. So these indices do not change, but rest everything that is here, right? So now if I talk about this index, this is 0 comma 1, and this get exchanged with 1 comma 0. Yes or no? This is 0 comma 1, this get exchanged with 1 comma 0. Yes or no? Yes. What about 0 comma 2? This get exchanged with this one, which is 2 comma 0. This is 0 comma 3, it gets exchanged with 3 comma 0. Okay, this is 0 1 2 3, 0 1 2 3. This is 1 comma 2, you exchange it with this one, 2 comma 1. This index is 1 comma 3, you exchange it with uh, this one, which is, oh sorry, this one, 3 comma 1. and this is 2 comma 3, you exchange it with 3 comma 2. So effectively, can I say that if there is an index aij, with what value will it get swapped? The element at aij, where it will go? Array of j comma I. Absolutely correct. Right. So can I say if I know the diagonal, I can iterate on one part of the array, either on the top part or on the lower part, either on the top part or on the lower part, and then I can swap the elements like this. Aij is equal to aji. Does it make sense? So what is the property of the elements which are above the diagonal? How do I get to know whether the element is above the diagonal or not? Element above diagonal. So if you look carefully, the column number, that is j, is actually greater than I. So all elements which are above the diagonal, they have a column number that is greater than the row number. Absolutely correct. The j is greater than I. 1 comma 3, 3 is greater than 1. 2 comma 3, 2 is 3, 3 is greater than 2. So yes, that is true. So if I now iterate over the entire array, what I need to do? What I need to do? I need to swap, right? So can I say the code would look something like this? I'm going over all the rows from 0 and I'm going till the last row. I'm going over all the columns. J equal to, can I say if j is greater than I, I can start this from I. See, in the ith row, I can start this from I plus 1. Does it make sense? Or you can start it from 0 and then you can check if j is greater than I. That is also okay. See, in the 0th row, you will start from first. In the first row, you will start from second column. In the second row, you will start from the third column. In the third row, you do not need to start. So uh, even if you start from the fourth column, but that loop will not run because j has to be less than n. So does it make sense? This will make sure that we are iterating only on the upper triangle. Let me know. I'm starting from I plus 1. That ensures that j is always greater than I. Not really. Not really. It does not. So what is happening? In the worst case, you're iterating n square by 2 times, which is still order of n square. So it does not actually improve the time complexity, although running time would be better. Can we start both the loops from 0? Yes, you can start. You can say, okay, j will start from 0, and then you put something like if j greater than I, then I will do the swapping. So that is also okay. Right now, I'm not using any if condition because I know j is greater than I. So can I just simply swap is a function which exchanges the values of aij and aji. Okay, so I've written some code that swaps aij with aji. So this will give me the transpose of the array. Now let me know if it is clear or not. Clear. Okay. Will it be more easy if we use another matrix? See why waste space, right? It's not difficult. It's easy, right? Do we use set here? No, no. Set is not needed. Dimension is changing. No, no. It's not. I'm saying it's a square matrix, right? So dimension will not change. So this is optimal in terms of space complexity. Yes, it is optimal, right? So we are using n square time, and we are using order one of space. Absolutely correct. So it is a optimal way of doing it. See, swap is one function that you can define. Okay, and if you are using array list, you can say, okay, I will copy some. How do you swap two numbers? Do you remember how to swap two numbers? I say, okay, there is a bucket 10, there is a bucket 20. What I will do, I will create a temporary variable. I will put a here. Okay, I'll put b into a. Okay, and I'll put temp into b. So this becomes 10. So this is something that you will do inside the swap functionality. So you pass the array, you pass ij, and here you write the code to swap the two buckets. Okay, so that's what you are going to do. It's not a technique. You can create one small helper function to do this work. So it got little stuck. Oh yes, Chirag. That is also one way to do it. So Chirag has given me one technique which also works for swapping two numbers. You can use that as well. So let me just discuss what Chirag has told, telling us. So swap two numbers without using a temporary bucket. Yes, that is correct. So if you have array of numbers, it will work even for a 2D array. Okay. So Chirag says, okay, if I have a number x which is 10, I have a number y which is 20. So in the first step, I will do x is equal to x plus y. So this makes the value of x as 20. Then it says I will subtract from x the value of y. So this actually makes the x as 30. Yes, it makes the x as 30. Then from the x, he says I will subtract the value of y. So what is the value of y now? So 30 minus uh, y, which is 20. So y is 10. Okay. And in the third step, he says, okay, from the x, I will subtract y. So y now contains the value of x. So from the x, which was now containing x plus y, we are subtracting the original value of x. So y is now holding the original value of x. So it is now 30 minus 10, that is 20. So x is finally 20. So if you look at this and this, the numbers are actually swapped without using a temporary variable. So this is a nice trick that you can learn, so without using a temporary variable. So thanks, Chirag. Yes, this is also another way. Yes. What if it is not a number but an alphabet? It will still work with alphabet because alphabets are also numbers. Alphabets are also numbers, so it should work. Yes, yes. It's it's a Viva question in college, right? Does it really save some memory space? The answer is no, since temp is just one bucket, and we do not count one bucket as extra space. So it's okay to use temp and do this. So company is not going to judge you on this technique whether you know this or not. So it's okay to use temp as well. Will this work in matrix rotation? Of course, yes. Now, what is x? X is your aij. What is your y? It is your aji. So you can say, okay, I can do the same thing because these are also buckets. It can work. Okay, you can write your swap function using this technique, which is okay. Okay, now let me give you a question that given a array, given a n cross n array, print the mirror image of the array. Print the mirror image. For example, if the array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in the mirror, it would look something like this: 4, 3, 2, 1, 8, 7, 6, 5, 12, 11, 10, 9. So how do you convert this array into its mirror image? Come on, guys, let me know. Vinay says reversing each row. hmm Absolutely correct, Vinay. So if you look carefully, what we are doing, we are actually reversing every row that gives us the mirror image. So mirror would mean that the left part will go into the right and the right will go into the left. Okay, so that's pretty easy. So if you have a function called reverse, what do you need to do? You need to go to every row and reverse that row. Reverse it. Okay, and how do you reverse a row? How do you reverse the array in place? How do you reverse the array in place? Okay, people are saying two pointers and swap. Absolutely correct. So you keep index here, a variable here, a j here. You say, okay, in the beginning I is 0, j is at n minus 1, and while I is less than j. I will swap these two. So 6 comes here, 1 comes here. Then I say, okay, swap ai with aj, and I do I plus plus and j minus minus. So I comes here, j comes here, 2 and 5. I swap it, 5 comes here, 2 goes here, I goes here, j goes here. So I swap it, it becomes 4 and 3. And after that, the loop will stop, right? So we swap the left part with the right part, and that's pretty easy. So you can do it. So do it yourself. So I'll not write the complete code. So you need to go to every row and reverse it. Does it make sense? Now there is a question by Pranav. Will it work in metric rotation? Yes. So now there is a popular question. Uh, it's a popular interview problem as well. So sometimes we are given that we have a matrix. We have a square matrix of size n cross n, and we have to rotate it 90-degree. Okay, rotated by 90-degree. For example, if the matrix looks something like this, the output should look like something like this. The output should look something like this. I just got stuck. See, if you just rotate it by 90 degree, what will happen? This row 1, 2, 3, 4, 1, it will get converted into a column. Yes or no? If you flip it by 90 degree, this is how where it will be, right? Great. The second row 5, 6, 7, 8, it will be like this. Okay. Then the next row would be 9, 10, 11, 12. And then it would be this one 13, 14, 15, and 16. So this is how it is going to look like. So one thing, so now there are actually there is a hacky way of doing it. I will try to give you a, and it is the easiest way also, right? So I'll tell you how do you do it. Okay. So one thing you can observe is that the rows are getting converted into columns. So what operation converts rows into columns? Who will tell me? What operation converts rows into columns? Great. So we just learned about a transpose operation. So what we do, we will take a transpose and let's see what result do we get. So if I flip all the elements about this diagonal, it will become, the diagonal remains same, 1, 6, 11, and 16. But rest everything is changed. 5 and 2, 9 and 3, and 13 and 4, then 10 and 7, then 8 and 14, then 11, sorry, 8 and 12 and 15. So 15 and 12. So this is what you get after the transpose. Can you relate how this array is related with this array? We have to do one more operation. See, this is the first column, this is the second column, this is the third column, and the fourth column. So now this column is actually here. This column is actually here. This column is actually here. And this column is actually here. So that means if the columns are 1, 2, 3, 4, so then they are written like this 1, 2, 3, 4. Mirror image. Absolutely correct. So that means in order to get the mirror image, we have to reverse every row. So if you go to every row and reverse it, so it becomes, okay, I go from 1, 5, 9, 13. I say 13, 9, 5, 1. Great. I say, okay, I go to this row 2, 6, 10, 14. So I say 14, 10, 6, 2. I go to this row 15, 11, 7, 3. I go to this row 4, 8, 12, 16. So it becomes 16, 12, 8, and 4. So now if you see, this is actually same as this. So what we had to do, we have to do two operations. One is the transpose, second is the mirror. That's it. And our array is flipped by 90 degrees. Okay. This is the easiest way to solve this problem. And the code part you can do, right? So you just need to combine the two operations one after the other. What is the time complexity? Hmm. You have n into n elements. So you have to iterate over all the elements. It will be n square for the transport, n square for the mirror. So adding will still make it n square. What about space? Are we taking any extra space? No, we are doing it in the same array. So it's order of 1. Okay. For anti-clockwise, should we take across the other diagonal? Probably yes. You can try it out. Okay. So it would be very similar. You can try it out at your own. Mupa says, for this question plan, can you please code it up? So Mupa, I've already coded up, right? This is the logic that you need to apply for every row for doing the reverse. Okay. And for the transpose part, what we did, we already learned how to do the transpose. So this is the part one, the transpose part. Okay. Part two will explain you. Part two, if it is not clear, you need to say, okay, I need to go to every row for I equal to 0, I less than the n I plus plus. I need to say, okay, I want to reverse that row. So I am at a ith row and I want to reverse it. So can I say I have something x here, some y here, and I can say x is 0, y is at the ending of this row, which is n minus 1, and I can say while x is less than y, let me swap array of ith row x column with ith row and the yth column. And after this swap has done, I have to say x will move to the next index and y will move to the previous index. That's it. So this will swap my every row. Does it make sense, Mupa? Swap means mirror image, mirror every row, mirror or reverse. So this element goes here, this comes here. Similar, this goes here, this comes here, and so on. It goes on for the entire row. So do it for all the rows. Okay. So try it out. It should be easy, right? All right. So with this, we are done for today, and the next class we it would be on some interview problems on arrays, and there won't be a class on this Friday. So next week we will start a new topic, bit masking, and we don't have a class this Friday so that you can go and revise arrays. So Wednesday we'll do interview problems, and Friday is a off. Okay, so make use of this time and cover any backlog. Okay. So Kintan, you are using that 90% off. All right, thanks for it. Is there a way to sync scalar calendar to personal calendar? Maybe in your phone, you will have the setting what calendars to sync in the app. So it should be there. Okay. Bye bye everyone. Good night and take care. See you on Wednesday. Good night. Good night. Bye bye. Bye bye.